So, Michael, one of the things that I think some people get confused about is really understanding what attenuated live bacteria means. Can you kind of explain what an attenuated live bacteria is?
Sure. So in the context of live bacteria, attenuated typically refers to having reduced toxicity, and that can be done by eliminating the LPS genetically and completely, as many companies are doing. But it can also be related to the fact that many bacteria and viruses produce toxins. Okay, so and many of the diseases, the viral or bacterial diseases that we're susceptible to, are not just caused by bacteria dividing and growing in our body, but also by toxins that are produced. So as a matter of fact, one of the most common ways of making vaccines is to take a bacterium or a virus and to attenuate it, to get rid of a toxin which may not be needed to stimulate the immune response. So it really basically refers to any setting where you've reduced the toxicity. And so that can apply to either a live bacterium, or it can apply to killed bacteria. Now, there are some settings where people do use the term to refer to killed. And so you have to be a little careful when we talk to people about it and talk to experts, because historically, sometimes people have used the term attenuated for killed. But it's important for our purposes to distinguish between that, because on the one hand, we've attenuated the bacteria by reducing the amount of LPS, but in addition, we 100% kill the bacteria.
For killed bacteria, is there anybody else that you're aware of that right now is using killed bacteria in a systemic therapy?
Not that I'm aware of. There are companies that have used or are using fragmented bacteria. So I'm aware of groups that take bacteria and blast them apart one way or another, produce fragments, and are trying to develop those as therapies. But I'm really not aware of any companies using intact killed bacteria. And in fact, we've actually gone a little bit beyond the intact and killed by stabilizing bacteria. As you know, the method that we use to kill the bacteria actually stabilizes them, and we've demonstrated this in the lab. And we think that this gives us an additional advantage, which is when we inject the bacteria, we don't want them to fall apart before they've gotten to the liver or the spleen.
And falling apart is called lysing, correct?
Yeah, we don't want them to lyse. And bacteria, they can be a bit fragile, and the immune system has various ways. When the immune system sees bacteria in the blood, there actually are mechanisms for lysing bacteria. And we'd like to keep them intact before they get to the liver or the spleen, where they can have a major immune activation. So we also have this novel way of stabilizing the bacteria.
Now, when we talk about bacteria, we kind of use this as a general term, but the reality is there's different types of bacteria and strains.
Right.
Is there anyone working on the similar type of bacteria that we use relative to some of these attenuated live bacteria? Are they a different type of bacteria?
People have worked with both. So most of the companies working with live bacteria are actually working with gram-negative bacteria. And as you know, that's the type of bacteria we work with. And gram-negative bacteria it's a very broad collection. I mean, basically bacteria are divided into two groups, gram-positive and gram-negative. And that's just a historical observation when Dr. Graham tried to stain bacteria. He found that some bacteria were stained easily and some bacteria were not stained easily. And what he found, he didn't realize this, but of course it turned out that he had actually stumbled upon a major difference between two groups of bacteria, one that has a very thick cell wall and one that has a very thin cell wall, and that's why we have a difference in the ability to stain them. Now, what was discovered later is that it's the gram-negative bacteria that have lipopolysaccharide. The gram-positives have some similar things, but not true lipopolysaccharide. So that's why we're focused on gram-negative bacteria. And we've actually created decoys with more than one strain of gram-negative bacteria. And because we did that, and because LPS is the defining hallmark of the gram-negative bacteria, and because all gram-negative bacteria have it, we've been very fortunate that we've obtained patents that cover all gram-negative bacteria, and that's certainly been important for our approach.